Hello everyone, hope you are all doing well. Let's check this integral. So, an idea to solve this integral is to see what bothers us the most. What bothers us the most is this thing over here. So a good idea would be to let u be equal to x squared. Okay, now from this here we can say that du equals dx squared, which means du will stay as it is, du. Dx squared, what is the derivative of x squared? Is 2x, and we will just add a dx over here. So, now we need to substitute the things we have found over here, which is instead of x squared over here we will put u, and we have x dx. Do you see it over here? So we need one more step actually over here. We will solve this one, x dx equals to 1/2 du, and now we will substitute. So we have the integral, the indefinite integral of x times e x squared dx equals to x dx, this thing here, equals to this thing over here. So I will put the integral, and I will put 1/2, and I will put the du over there. I'll leave a little space over here. E x squared. E x squared is equal to u. So this was it. Now we see that in this integral over here we only have x's. In this integral over here we only have u's. So one more step over here. Let's get 1/2 outside. Eu du, which is equal to 1/2 times eu. Don't forget the plus c. Are we done? No, because the original integral had x. We need to convert this back to x. This is very easy. 1/2 times e. What is u? U is this thing over here. X squared plus c, and this is the solution of the integral. Now, let's check a different solution for this one, a much faster one. Let me erase all those. And I'll leave only the answer of the integral here. As a reference. We have the black integral. We know that the integral and the derivative cancel out themselves. So the big question is, how can I write this thing as a derivative in order to cancel out this integral with this derivative? Let me put this down here. So let's think, what is needed in here to fill this derivative? Any ideas? Well, the part that bothers us the most is this one. Let's find the derivative of v on the x squared. Isn't this x squared derivative times e on the x squared, which is 2 times x times e on the x squared? Do you notice something? This part over here isn't exactly the same like this one? What bothers us now? What bothers us now is this 2 times. Is this 2 over here? Okay, no problem. No problem at all. Let's do a little trick. Let me erase those first. What bothers us? This 2 over here. Let's divide with 2. So let's calculate the derivative of v on the x squared divided by 2. This would be 1 over 2 times the derivative of v on the x squared, which means 1 over 2 times this thing over here, times 2x. Yeah, but pay close attention now. This cancel out with this one. And what we have left is x times e on the x squared, which is the same like this one. So, in other words, what do I need to put inside here in the parentheses, in the derivative? This one. E on the x squared by over 2. And now I can cancel out the integral and the derivative. I can cancel them out. And what's left is e on the x squared divided by 2. Do not forget the plus c. And as you can see, this is the same thing like this one. And that's all for today. Hope you enjoyed the video and found it helpful. If you did, please consider subscribing to the channel. That helps a lot. Make sure to like the video and leave me a comment with what you would like to see in the future. See you on the next one. Bye.